Okay, so in this video we're going to do two examples here. We're going to be solving equations, not so much modeling in this chapter, but we're going to go ahead and it's the extension primarily doing last chapter. We're going to go ahead and solve for x. We're going to write the solution. Make sure you're rounding to the nearest hundredth. Round how I'm asking you to round. And so what we're going to do here is, because I'm solving and my variable is an exponent, I need to use a logarithm to bring that down. So I'm going to introduce a log base 10 on both sides, and remember the log is not written, so it's base 10. So what happens is this whole piece gets brought out to the front. It's being multiplied. So now I can use technology, or my calculator, to get rid of these logs by dividing them out. Okay, so then I have x minus 2 is equal to log 25 over log of 5. And so I'm going to go ahead and reduce this, and I'm going to have x minus 2. You can pull out your calculator, or possibly this is something that maybe you might know what to do in your head. It's a possibility, but if you don't, that's fine. And so we're going to go ahead and get 2. So log 25 divided by log 5 is 2. Think about 5 to what power is equal to 25. That's kind of what this is happening right here. And then so I'm going to add 2 to both sides. X is equal to 4. And if we look at this, think about the actual statement. In order for 5 squared to equal 25, x has got to equal 2, right? Or excuse me, x has got to be 4 because it's 5 squared. This is how we'd go through the process without using a calculator if we needed to. So here's our next example, and we're going to solve this, and this is actually an extension of one of our previous properties, and we're going to actually solve this, but we're going to condense it into a single logarithm. And so that means I'm going to have natural log of x times x plus 1 is equal to the natural log of 2. Because I have this one-to-one property, I have 2 logs on either side, same bases, equal to each other. I can ignore the logarithm, and now I have x squared plus x is equal to 2, and it's a quadratic that I can factor. What two numbers multiplied to negative 2 but add to 1, x plus 2, x minus 1. So my solutions are x is equal to negative 2 or x is equal to 1, but we have to do a check. Okay, I'm going to go with the negative 2. Does this work? E to what power is equal to negative 2? It's never going to happen. I'm going to throw that out because we can't raise a positive number to any power, any real number, and get a negative number. So 1 is our only solution. So the two examples that we just talked about are extensions of stuff that you've already seen in previous sections. So it's a little bit of review in this chapter, but it's a good way to solidify these skills that we've already talked about.